Okay, so up until now, we've seen that JavaScript has functional implementations of higher order functions very similar to those found in Scala. And we saw one example of that in use, filter. Now we're going to continue with a different example, map. I think it's good to start simple, so we're going to start by seeing how map can be used to square root all of the values in an array of numbers. So I'm first going to type this new array called numbers, set its first elements to 1, 4, and 9, as such. And this would be a good time to point out that map does in fact make a new collection whenever you call map on an old collection. So what I'm going to do here is I'm going to make a new array, I'll call it roots, and then that is going to be the result of mapping the function math.squareRoot to every element in numbers. And now, so what's going to happen here, this is a higher order function. We passed in a function as a value to the function map, and that is going to go through every element in this array numbers that we have here. It's going to perform square root on 1, it's going to perform the square root on 4 and on 9, and then we're going to get back this new list that is going to be all of the numbers, but they're square rooted. Pretty good, right? So we see that roots is now 1, 2, 3, and numbers, it's still 1, 4, 9. Okay, so that's fine and dandy, but why is that awesome? I think it's useful to show what you would have to do without higher order functions to get the same result of square rooting every element in a list. So let's see how that would work. I'm going to make a new empty array. I'm going to call it complicated roots. And then I'm going to type your canonical for loop with a variable I set to 0 going until I is greater than or equal to numbers.length, I++. You've seen this all before. And now I'm going to take this new complicated roots and I'm going to push the results of square rooting each element of numbers into it. And this is what that code looks like right here. And as we see, if I print out complicated roots now, well, it's going to be 1, 2, 3, square rooted. And if we notice here, comparing these two, we have in just 35 characters what takes the old way of doing this stuff 116 characters. And that's why functional programming is awesome. You write better code with less bugs in less time.